चलो दोस्तों शुरू करते हैं विदाउट वेस्टिंग ए टाइम. Today in this video we are going to discuss about the EVPN theoretical part. So we will discuss about the EVPN building blocks. So these are the building blocks of the EVPN. EVPN instance, which we say EVI. EVI. This help us to identify the VPN in the network. Okay. And secondly, one more term is Ethernet segment. Ethernet segment represents a site connected to a one or more P. Here in this topology, we can take the example of CE2. CE2 is connected with the this leaf 1 and leaf 2. You can say these are the PE router PE1, PE2 is connected between behind the two PE. So with the help of ESI, we can identify that this device is single domed or dual domed. And EVPN having a different type of route. So majorly there are the five type of routes: Ethernet auto discovery type 1 route, type 2 is for the MAC and IP advertisement route, type 3 for the multicast route, and type 4 is the Ethernet segment route, and type 5 is the IP prefix advertisement routes. Okay. If we talk about the BGP route attributes, major are the MPLS label. You will see ES import community, MAC mobility, default gateway encapsulation with the C. And there are the two major type of encapsulation for the BGP EVPN. One is the network virtualization overlay, and which is VXLAN. Other is the MPLS. Okay, MPLS you will see in the service provider domain, and the VXLAN mostly you will see in the data center, like in the Nexus case, encapsulation with the VXLAN. Okay, so like in the previous video, we have seen that in the case of dual home, one of the P is selected as a DF and DF forward, and another is the DF blocking. Okay, what is the use of DF forward? So this helps us to prevent the duplicate copy of the flooded traffic from being delivered to multi-home Ethernet segment. For example, traffic is sent from the CE1 to CE2. Okay. So if let's suppose this leaf 2 will become the DF order, so only leaf 2 will forward this traffic which is received from the CE1 to toward the CE2, and leaf 1 will not send this, as this will be in the blocking state. So with the help of this DF order, we can prevent the duplicate copy of the flooded traffic on the multi-homed Ethernet segments. And this DF election will be per EVI per ESI base. So for the each EVI, for each EVPN instance, and for the each Ethernet segment identifier ESI, there will be the one DF. And one more thing is, what is the use of split horizon label? Okay, so this will help us to prevent the flooded traffic from the echoing back to multi-home Ethernet segment. What I mean to say that if CE1 have CE2 have led the some traffic toward the leaf 2, so leaf 1 will not forward this traffic to the CE2. This will be achieved with the help of split horizon label. Okay. And one more label we seen in the EVPN is aliasing label. Okay. So this helps us to the load balance the traffic toward a multi-home device when the MAC address are learned by the only single leaf. So you can see that like this CE2 is connected, okay, behind this 2P, leaf 2 and leaf 1. Let's suppose this CE2 MAC address is learning only on the leaf 2, but the remote end, when the CE1 is sending a traffic toward the CE2, with the help of aliasing label, he can send some traffic to this P, some traffic to this P. So with the help of aliasing label, he can do the load balance. And one more thing is how we'll achieve the MAC mobility. So MAC mobility, what do you mean that? To detect the correct location of MAC address after movement of host from one Ethernet segment to another segment. Okay. If some host is, if let's suppose there is some host is connected in the PE. Okay. This host got moved. Okay. And this host got from moved from this PE to, and that MAC is now we are learning from the leaf. Earlier, that MAC we were learning from the leaf 3. Now we getting the similar MAC we are learning from the leaf 2. Okay. To detect this, EVP uses sequence number, and obviously next will also change with the help of this. It will detect the host move. This host move majorly come into the scenario in the VM when the virtual machine moves from the one host to another host. So in that case, P devices in the EVPN domain can detect this with the help of sequence number. So sequence number will get the incremented. So higher the sequence number, out will be the prefer, and also the next will also change. And here I mentioned the use of the routes, like route type 4. This is the Ethernet segment route. Okay, Ethernet segment route. So this will say this will help in the election of TF. Okay, this will inform like the I have an ASI one in case when someone need information for the DF election. So in the DF election, route type 4 will play the role. Okay. Route type 1 is the Ethernet auto discovery AD route. Okay. So this with the help of route type 1, all P will in the EVPN domain come to know all of the configure all active. Okay. And what are the attachment circuits, or what are the devices are connected behind this, what are the EVI connected between this two leaf 1 and leaf 2. Okay. And in the route type 1 only will get the split origin label which we have seen. Okay. And aliasing label. Okay. To get the load balancing, and split origin label to prevent the flooded echoing back, or you can say loop of the traffic. And route type 3 for the bump traffic, for the multicast traffic, for the bump traffic, bump label will come from the route type 3. Okay. And route type 2 is the MAC IP advertisement routes. Okay. And route type 5 is the prefixed advertisement routes. Let's see how the bump traffic will be handled, like the broadcast, unknown unicast, and multicast traffic. Let's see, the C2 is send some bump traffic to the leaf 1. Okay. And leaf 1 have sent this traffic to the leaf 2. So there will be the three label stack. One is the transport label, or you can say the prefix seed or node seed with respect to segment routing. Then is the bump label for this EVI 200. Okay. And this is one is the split origin label for the Ethernet segment. So split origin label, as we discussed earlier, to prevent the flooded back from the multi-Ethernet segments. Okay. And with the help of bump label, this leaf 2 will identify this is a broadcast, unknown unicast, or multicast traffic. And this bump label will come into the picture from the route type 3. And route type 3 is for the bump traffic. This bump label comes, and this split origin label will come from a route type 1. Okay. Transport label, again, if we are using MPLS transport label, or in the case of segment routing, we can say this will be the node seed. Similar way, if this leaf 1 is sending a traffic toward the leaf 3, so there will be the two label stack. When the transport label or prefix it to reach to this node leaf 3 from leaf 1, and second with the bump label again for the EVI 200. So this leaf can identify this is a bump label. Again, this bump label will learn from a route type 3, which is the inclusive multicast route. And if we see about the unicast traffic forwarding, so the two labels like transport label, or we can say prefix seed, node seed, and then the router to MAC label per EVI 200, then unicast traffic. So let's suppose this C1 is have they send some traffic to the C2. Okay. So outer label, the transport label or prefix it to reach this leaf 2 or leaf 1. And second label with the router to MAC label for the EVI, which EVPN instance they are taking apart. Okay, then the unicast traffic. And here also, while doing the unicast traffic forwarding, as the on the per flow basis, the load balancing can be achieved with the help of LEIC label, which we have seen earlier. So you can see that while this C1 will say for the traffic, so on the one packet it can change the transport label on the per flow base for each flow. So it will first time it will put the transport label for leaf 2 and router label for the EVI and the unicast. And the second flow it can put the outer label transport label fix it for the leaf 1, and then router to MAC label EVI and the unicast traffic this way, with the help of a licensing label. So it can achieve the load balancing also. So from this topology, I have captured the few outputs where the C1 is the dual DOM, the P1 and P2. P1 is the 1.1.1 and P2 is the 3.3.3 and PE3 is the 4.4.4. So here you are saying we are checking the detail of show BGP into EVP and RD for this P and this detail we are checking. This is the table for the route type 2. Here we are seeing the two label. This outer label is the BD label. Per BD label, this is the VRF aggregate label. Rest of the things self-explanatory. And here we are checking the entry for the route type 3. Okay. Under the route type 3, this is the tunnel type 6. Tunnel type 6 means ingress replication is configured. And this is the bump label. As type 2 is the multicast route. So this is the label for the bump traffic. And here we are checking the show EP Ethernet segment for this carving detail. So what we are saying here, we are saying that this PE, this elected as a DF order, EVI elected E. Okay. And here's the non-forwarder. And here we can see that this is a local split origin label it's showing. And here I'm checking the PE1 for the route type 1. On the route type 1, What we can see, this is the important thing to note, that this is the EVPN label, this 0.0. This will tell us if the single active or all active are configured, and this label 256. Okay, and this label is the licensing label, and this label 256 is the your split origin label. Okay, in our topology, this is the people. This output are going from the Cisco Live.